Hey guys, sitting in office hours, waiting for some people to join. Just had a nice 50-minute conversation about some stuff that I'm sure you guys will see. But while I'm sitting here waiting for people to join, I wanted to do a paper review. I haven't done one of these on the channel, although I do them quite a bit in my business day to day. Usually I take one of these papers or something like that, a project, and write the code and everything like that. But since I'm already sitting here waiting in office hours, just a quick note, office hours is for our Discord group. Link will be down below. Talk about data science stuff all day and every day in our Discord. So definitely want to join. But wanted to go through a paper that I saw probably about a week ago. But it was really interesting. It was something that I had thought about for quite a long time. An idea that I thought worked in practice for a long time. I'm glad that somebody actually made this into a paper. But yeah, let's take a look. Let me share my screen. So the paper is called LapDoc, Layout-Aware Prompting. The general idea, as they're going to kind of put here, is that LLMs, if you, so let's think about this. Let's think about, you take a document, you pass it through some sort of document extraction tool like Textract or Azure Document Intelligence or stuff like that, or maybe you're just using like an OCR model, like a, I don't know, like a paddle or something like that, and you get all this information from the document. And then you, if you're doing like a chat with document use case or something like that, you pass it to the LLM, you ask it questions, or you do things like that, and it returns, it looks at the document, returns results. You know, if you're doing like RAG, it gets stored in a knowledge base. You put in your query, you retrieve information, you answer the question or query, whatever. But when you, in a lot of cases, pull that information out with some of these document intelligence tools, the information doesn't have the same schema that the document has. So like titles, and headers and things like that, they don't read, they don't have the same level of meaning to an LLM that just sees, hey, this is text, right? Like, it just sees that there's text and that's kind of it. But we know that, based on the way the document was laid out, that should have had a little bit of meaning, that text in documents doesn't read just left to right. It has some sort of structure, it has some sort of schema. And if you preserve that structure and schema, that should help the LLM understand what some of the information in the document means, right? A great example would be, if you have like columns and you have a bunch of rows, well, you don't want the text to just be pulled out and then read left to right, where you have all the columns in one row and then you have all the row values going down, because you need to correlate the row information to the columns. That text doesn't have the same meaning. So you want to extract the information from something like that in a way that preserves the understanding that this column matches to this row value, this column matches to this row value. You want to preserve that information so that the LLM can best understand how that information is actually supposed to read, right? Documents aren't like books. They don't just read left to right. They have some sort of schema in them, some sort of format that you need the LLM to understand. So that's kind of what they're talking about here. They do an introduction. I don't really read these. They're talking about how, hey, documents have a bunch of information that you need to understand with different document types, such as formats, forms, complaints, reads, less standardized types, right? That's the other idea here, is that, a lot of these files like invoices and receipts and things like that, there's not a standard format. Everyone has a little different, way that they structure the document and things like that. They're just kind of pointing that out. Understanding documents clearly necessitates understanding of textual and visual modalities, as well as comprehension of spatial relationships between the document's content and elements. That's what I was talking about. So like, the spatial understanding of where words are matters when you talk about key value pairs, when you talk about columns and rows, when you talk about these things in the way that documents are actually presented. Spatial understanding of where those words are, how far away they are, how much space is between them matters, right? You put information in a box in some sort of document, then that reads different than just extracted left to right, where you have no understanding of where that was relative to the other information. Hoping they show an example here at some point, because that would help quite a bit. Maybe I have an example. Let me see if I have one. Let's see if I have one. Give me a second. I want to make sure. I get this right. I want you guys to understand what I'm talking about. This is a good example. Let me reshare my screen. This is a great example. So this is a medical document. Whatever. Very, sort of structured here, whatever. When you process this, if you were to run this through an OCR that just does, pull text out left to right, a lot of this information, pretend these, let's see if I have an example without it now. Imagine these green boxes don't exist. Those aren't in a normal medical document. If you were to pull this out, all these sections would kind of run together, right? Current medications would run into this reason for appointment. This last item in the list of current medications would run into this other box right here. If you can see that, like, the way this document is actually laid out are these little boxes of information. But if you use a lot of these document extraction tools, they don't preserve or understand that exists. They just pull the text out. It reads left to right. And what ends up happening is information sort of combines together, blends together. There's no understanding of the structure of the document. This is actually a pretty good example of that, due to the fact that if you were to pull out, let's say, the review of systems section, it would run into the examination and the assessment section. They would just blend together because it's just going left to right. And so that information just combines right into it. So let me go back to the research paper. That was actually I'm glad I pulled that up. That was actually a pretty good example. So let's go back, research paper. So they're talking about, sort of how, they're talking about how OCR works. I don't really know why they're going into that in so much detail. One of the most prominent reasons developed. Now they're talking about LLMs. This is an introduction section. The study would focus on an LLM-centric document comprehension pipeline that fuses the text with document layout. So that's kind of the general idea. We want to be able to use an LLM with these documents, but we need to design. I use the term document understanding. They're using document comprehension, but understanding the schema of the document so that an LLM can better understand. And that was something that people thought made sense, right? If you can improve the way that the document's formatted in the LLM prompt, you probably get better results. But it wasn't something that had really been explored as much. This paper focuses on that. Pipeline offers two benefits. First, it exploits the superior knowledge, capacity, reasoning capabilities of LLMs, which at the present time have been trained at blah, 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 blah. Second, I don't need to go into details about what an LLM does. Second, which is relevant for practical applications, the pipeline offers the benefit of simplicity since it involves no model fine-tuning, thereby allowing us to keep a single generalist model. Cool, whatever. We focus on the key step of document verbalization, which raises several interesting questions. How well do LLMs perform at document comprehension tasks that involve challenging layout reasoning, even with little to no information on document geometry? How are LLMs influenced by the way we feed them document representations? And particularly, can we alter the document representations in a way that allows the LLM to exploit document geometry to achieve the same performance as a multimodal model. This is the key. This is really what the paper is about. Can we use a step in the pipeline of data extracted from document, LLM, to format the information in a way that improves comprehension, that improves the way that the LLM understands this document, even with little or no information on document geometry. So in the most raw state of information extraction from the document, can we improve this when we don't have that option of some of these really good sort of spatially aware document processing systems and things like that? And they're going to run some tests on 2 LLMs. They kind of chose, when did this paper come out? Oh, February 2024. I don't love that they chose 3.5. I guess 4 was out. 4 was out in February. I wish they would have chosen 4. And I don't know what the hell LLM Solar is doing in this paper. There's better LLMs that are open source. Yeah, whatever. It's fine. General idea is yeah. I wish they would have used 4. I don't mind using 3.5. I don't mind using Solar. Kind of wish you had used 4 as well, because most people are using 4. Novel overall. So the overall contributions of this paper. Let's look at that. A novel rules-based approach that enriches the prompts of existing text-centric LLMs with spatial structure information from documents. So we're going to see that the goal of the step that they're putting in place is to add spatial awareness to the text when provided to an LLM. Various kinds of documents applied without the need for fine-tuning. Cool. A set of comprehensive experiments using both research and real-world document data sets, as well as commercial and open source models. Cool. Wish they had used GPT-4, but whatever. Explore LLM limitations when it comes to interpreting document layout in depth. And discuss efficiency issues, blah, blah, blah. If you're doing document processing with LLMs, you understand the efficiency stuff. These are large documents. I don't, whatever. Related work, I don't need, this is just focused on what are LLMs. Multimodal models, the idea here. Oh, okay. Well, I see why they didn't use GPT-4, because it's multimodal. Duh. They were trying to choose models that are just text-based. Fine. This is actually totally valid. Multimodal, they're explaining what multimodal is. Cool. Yeah, they're explaining what multimodal models are. Approach. So let's take a look at the approach. Given a document, we extract its text and corresponding word geometries using off-the-shelf OCR solutions. The document is converted into a purely technical representation using a step we refer to as verbalization. We propose, they have different strategies for doing this. I'm sure based on kind of like what your goal is and what the document types are and things like that. To study the robustness of the verbalization with respect to inaccuracies of OCR, we degrade the OCR before verbalization. Okay, so they're trying to make it as hard as possible. They're trying to figure out, like, with messy and harder OCR tasks, does this still apply? Which I appreciate them doing that. So document comes in. They are adding some noise. Degrade OCR to word positions. Oh, so the noise is just, so like when you run these OCR models, you extract the text, but you get bounding box information about where, with pixels, like where is that word. So you get this bounding box information out. You don't just get words, you get bounding box information with the words. They are adding this noise to change the bounding box information a little bit. They're trying to make it a little bit harder, which is fine. So the noise, it affects the coordinates of the text we've extracted from the document. We run the verbalization strategies. We prompt the model, and we answer the question. Really, this is going to focus on what these verbalization strategies are. Everything around that should be pretty clear, right? You've got your OCR. They're doing this extra step to make it a little bit more complex. And then you prompt the model to do whatever your task is, right? Answer extraction in this approach. Verbalizers. So they laid out a couple ways that you can do this. We'll take a look at each of them. I'll give some thoughts on them. Strategies to create a textual document representation from an ordered collection of bounding boxes, like I mentioned, and the text associated with these boxes. This representation can serve as an input. Outline multiple different verbalization strategies. The following for each, we include the verbalization of an example word box with the text tax invoice and the coordinates being that, with a center point being that. That's a very standard output from what you would see from an OCR model. Some sort of text string and the coordinates of that text string, and then whatever the middle point is. Very, very standard. So plain text, they're just setting up a baseline without the layout information. This is, if you're doing a research paper, this is a great idea. You really need to lay out sort of that baseline of the most basic approach. Text lines retrieved from the OCR, not concatenated using new lines. They are concatenated using new lines to form the document representation. Cool, that's fine. Bounding box. Use both the bounding box coordinates and the text. So this would be something like what they show, where they just put in text, here's the bounding box coordinates, here's the text. So you can see they create this sort of like, I don't even know what you would call this, schema. You're just sort of saying the LM like in some sort of imaginary world, like here are the coordinates of this text. It kind of looks like when you like pull out the JSON from these things, from these OCR models, this is kind of what it looks like. I don't, it's fine. It's definitely worth trying. Bounding box markup. It looks kind of like exactly the same. It's just in like XML style. So you can see here we have the text and we have sort of like the XML format. This is kind of like the same. But it's worth testing these things considering how much XML and HTML text LLMs have been trained on. So I bet you they're understand like you probably look at this and you're like, how is that useful? Like, why would a model, like, how is that, like when you have no other spatial information, like how is that useful? I bet you it's actually pretty good, considering like these models are trained on a ton of HTML and a ton of XML text. Center point, it looks like it's exactly the same, other than they just give like they only give the center point. So like one, they give bounding box, the other one they give center point. I would be kind of curious if they gave both, although maybe they'll do that down below. No. Spatial format uses the geometries to restore the original document layout via insertion of spaces and new lines. To this end, the characters are placed on a grid such that their spatial location is similar to that on the document. I'll show you what this means down below, but essentially means like in your prompt, the text layout by using spaces and new lines looks identical to how it looks in the PDF. Spatial format Y, it only encodes spatial information on the vertical direction. Interesting. So same idea as above, just vertical. And then plain HTML, which is actually not a bad idea. Like I said, a lot of training here on HTML. So not surprised. Here's an example. I really want to focus on this. This paper doesn't have a ton of visual like approaches for this. I don't know why I can't zoom in. Oh, I'm all the way zoomed in. No. So I do really want to spend a bunch of time here. So this image on the left, this is the invoice. Like this is what the actual PDF file looks like. This is what the raw text looks like going into the prompt. So like if you were to pull up the prompt, this is what you would see. You can see a whole bunch of space, whole bunch of spaces. They try to keep sort of the distance between text or lack of distance between text exactly the same as you see in the document. You can see down here where it says change, and then you have a colon and you have a value. You can see the key value pair. They try to keep that exactly the same. You can see like here, you have tax invoice as like a subheader, and then you start getting the key value pairs. Same thing, tax invoice, key value pairs, same idea. This is what the text would look like, and it's actually, honestly, it looks really good. Like when you think about like comparing the actual PDF and then like the raw text format, they actually look pretty close. Like I was actually pretty impressed. And then you have this one, which is just plain text. Like this is what it would look like coming out of the OCR. This is what the actual text with no bounding box spatial understanding looks like. When I was mentioning like just reading left to right, this is exactly what I was talking about. You can see it just reads left to right. Anytime the midpoint of a bounding box is different, it just moves it down to the next line. This is why this paper exists, because the idea is that this sort of spatially aware structure is better than this. That is the idea. That is the idea we're looking at here. I know you can read that here, but I really did kind of want to go in on that. Noise models, OCR geometries generated by common OCR systems. Rare, they fluctuate. This is correct. Essentially, all they're doing is they are adding some noise because OCR models in production vary quite a bit, like across the different ones you use. So because they're trying to create standardization with this workflow, they're trying to mimic as much as they can, like the variation you would actually see. This is a really good job, like including this in a research paper. A lot of people that just want to publish like junk research and look really good would ignore this and just say like, hey, look, I used OCR, but they know that the OCR is like really good because of the specific use case. This is really nice. I'm not going to go too far into it, but that's what they're doing. They're adding noise. Prompts. They insert the verbalized document. They insert, this middle one or one of the other use cases that they use into a task-specific prompt template. As this prompt template influences quality, just like the verbalization, we aim to rigorously separate the effects of prompting from the effects of verbalization. Once again, they are isolating for this research paper just the effects of verbalization. This prompting provides a ton of variation, right? You change your prompts by one word, you get a very different prompt. So they are trying to standardize it for the sake of showing that this verbalization, just the verbalization, has this level of effect. Great research paper, great job there. I'm glad they mention it. I'm glad they do it. And then they talk about kind of how they do that, right? You have document, task, format. This is kind of what a lot of like document prompts look like. Like, I'm glad that they sort of laid this out how they did, because this is how a lot of them look. Yeah, I don't know really what else I want to add to that. Document corresponds to document. Task, those are, I usually call those instructions. You guys have seen that. Format used for, I don't know why they include this in the prompt. I don't really know why the prompt would care. I don't know. It's fine. Describes the expected output. This is, I usually call this like goal state output definition or something like that. But cool, works well. And this is kind of like an example. There's the content, there's the document. There are the questions they want to ask. There is the format. So like they're trying to say like what it is. I don't really know why you need that. This is the only, I don't know if you really need that, to be honest, with the spatially aware one. I don't know. And then they're doing a little bit of goal state output definition here. Nice. This looks pretty good. I don't mind it. Answer extraction. So going through now, the answer part, I'm gonna ignore that because I don't really think it's relevant to the. They're using answer extraction to understand the accuracy of the verbalization. Like, I don't know what else needs to be said about that. It's not really related to the verbalization piece, in my opinion. Experiments. Suitable verb strategy, export LLMs, better layout reasoning, provide exemplary comparisons of the open source commercial solutions. Awareness of the LLM towards layout aspect via accuracy on document understanding tasks. So they're going to look at some benchmarks and some benchmarking data sets for document processing with LLMs. Very nice. And they break down the different data sets. I don't really need to go through these. If you care a ton about these document data sets, you can check them out. This is a good one. Used it before. This is a good one. What else do I really like? I'm not a big fan of the HTML and JSON part of this research paper. I think it's fine. It's just not like what I usually use. So I don't really have opinions on that. These are great. Great data sets, especially when you look at like receipt processing, because it's hard. Receipt processing is one of the harder use cases, so I do like the inclusion of this. And then they get their own data sets. Look at that. And performance on 2 proprietary data sets from Insider Technologies, which proprietary, is this written by them? Yeah, it is. Okay. I was just interested why they're using a proprietary data set if it wasn't written by them, but yeah, it's fine. I wish we could see it, but it's proprietary. It's fine. LLMs set up the approach like we already saw ChatGPT and Solar. For evaluation of ChatGPT, we use that in JSON mode. Very nice. The temperature 0. Good. Enter each prompt in the role of user. It's fine. It's fine. It's honestly probably a good representation of what people actually do. I would prefer to put some of that in the system prompt and then put like just the instructions and the goal state output definition in the user part. But if you're trying to standardize this towards like what users actually do, because they're not the point of this research paper is not the prompting, right? It's the verbalization part. So it's fine. They're trying to make it look as real world as possible for what people actually do. They use Perfect. For each data set comes with a selection of pre-applied OCR engines. Oh, so they use whatever is in the benchmarks, because that data is like already extracted in those benchmarks. And then they use an open source and a managed service. Fine. I wish the benchmarks didn't already have some sort of pre-applied OCR and you were able to just run these. But it's fine. I don't think you're going to see a ton of variation there, especially on the data sets that aren't receipts. The receipts one, you will see some variation. The other ones, it's fine. And a bunch of mentions of what they do. They're using Solar. They're using data sets. They're using the do benchmark. Very nice. This looks like they're just talking about sort of the results or no, sorry, not the results, like the format. You can see currency values are sanitized using regex. I don't mind it. I actually really don't mind it. Cool. So results. Let's see what they found. I'm curious to see with just the verbalization piece, kind of what we get out here. Datasets with the metrics laid out, section aware, type aware accuracy. Results in table 1 and 2 show our approach can compete with state-of-the-art models. Interesting. We'll see what it looks like. Also, the do benchmark in table 1 demonstrate that the introduction of layout information to the prompt proves beneficial. Like I mentioned at the beginning, this was always my thesis, that spatially aware document layout outperforms unspatially aware, right? When you think about how information in documents, like I showed you with the medical document, when you think about the way information reads in those type of documents, and I wish they honestly would have used medical documents in this paper because they're some of the worst in terms of like left to right reading versus structure. I wish they would have used them. But I can't complain. Receipts are up there. Receipts are probably, a front runner for hardest as well. So I'm not complaining about that. But this was my initial thesis, was that this is going to be better. We'll see how much better. Approach achieves state-of-the-art performance on that. Very nice. The benchmark spatial format provides to be the best verbalization strategy on average. That is what I assumed, and I am so glad when we look at this that this is the best. When you compare it to the HTML, you compare it to the XML. There's nothing wrong with those, but it's extra tokens. It's extra tokens that don't actually provide you understanding in the prompt. The LLM has to look at the tokens you've provided, like the bounding boxes, and try to mimic that, which to me, I don't think text-based LLMs can really do. But this sort of just preset, like, look at my spatial, layout, just look at it. You don't have to like understand what these other tokens that show you the bounding boxes and things like that mean. You just have to look at the actual text. I'm not surprised that performs the best. I honestly wouldn't be surprised if like some of these barely perform better than none of it. Like, to be honest, other than the best one, I really think that. Back to where we were, provides best verbalization strategy. Peak gain of 15% on. That is not 15%. Is my math wrong? No, I'll look at the table, but 47 to 54 is not 15. Table 2 shows competitive results from the other data sets. I don't really want to read all this. I kind of want to just look at the table. Okay, so let's see what they used. Table 1, comparison with other models published on the Do benchmark. Underlines to note the best verbalization strategy in the data set. Shows that our approach achieves competitive results and even state-of-the-art results on 2 data sets. 15%. So, let's look at this. And I'm mostly going to look at DocVQA because I think that is the best, right? Table 2 has the receipt ones, right? Yeah. This is probably my favorite representation. Info VQA is fine, but I care a little bit more about Doc VQA, in my opinion. I think it's a little bit better representation of like difficult document schemas being broken down with these verbalizers into an LLM. I do really, sorry, it was a Latin prompt. I do really like their choice of models to compare to. Most of these are models that are built for document understanding. LayoutLM, Donut, It looks like they've got a little bit of a. Did they explain that pipeline somewhere? They've got T5, and then they're doing some stuff in there. I don't really know. It's not as good as LayoutLM, so I don't really care what they're doing. But they're using sort of what would be what most people, when you think about document understanding tasks, what they choose. They choose layout. They choose donut. Nowadays they choose Claude. Like now now they're just going straight to the LLMs. I can't tell you how many customers want document processing and think they should just run straight to Claude, or your other favorite managed service LLM. I don't know. But let's kind of take a look at what they get here. So you've got all the accuracies for these, and then you have. Do they? Oh, so they only use the underline for theirs. Okay, and then they have theirs. Spatial format actually performed the best for them across the board, other than this one, which it was only 0.2 behind. I'm going to count that as essentially the same. So I did think the spatial format would be the best. What I am not surprised about is the ability for LayoutLM to be the best. As you can see on DocVQA, 86.7% accuracy. Better than everything else in class. I am surprised at V2. I don't know what is that. Do they explain what QC is? 20. Sorry, I want to know what. Oh, come on. Why wouldn't you put what that is? Yeah, I know what I don't need you to tell me what LayoutLM is. Oh. Sorry, am I looking at the wrong one? Hold up. Doing a little sidetrack here. I want to understand for my own. No, it is 20. I don't know what that means. I'm trying to figure out what that is referencing. Sorry, we're on a little tangent here. Do they say? QG. What is that? I'm just kind of curious because LayoutLM v3 to me should outperform v2. But it's not just base v2. It's got a little extra on it. We'll keep going and see if I see what in the world they're talking about. I don't know. But I'm not surprised that LayoutLM outperforms this setup. My entire argument for customers when we talk about document processing, my entire argument is that you need to be using these open source layout document understanding models over just some LLM, even in a scenario like this where they were able to greatly improve the results that an LLM can get by using the document understanding, or sorry, the verbalizers. That these models like LayoutLM that are literally built just for document understanding are better. They are better. That's always my argument, and I don't know why I get a bunch of pushback by customers. Probably because they read some fucking LinkedIn post that said, document. Look at how great Claude is at document processing. Look, Claude not as good as LayoutLM, and one of those is fine tunable, and one of those isn't. But that's my rant on that. But that's I'm not surprised it's the best one. Looks very nice. InfoVQA, they actually do reach the best. Can I see like an example of this data set? I'm not as familiar because this is actually really all of these struggle. They mentioned that this kind of it's optimized for the data set. So like that's not a great representation. The prompt is optimized for the data set. So it's not a great representation. It still doesn't even beat what they did, which is not optimized for the data set. But let's have a look at this. Can I just see like an example one? Oh, yeah. Yeah, look at those. Yeah. So these are all infographics that exist in the data set. Wow, those are nasty. Wow. Okay. I'm impressed. I don't know why they didn't run. I'm seeing if they say it. I don't know why they didn't run this on it. I don't know. Maybe it didn't beat. I don't know. Maybe it wasn't one of the top ones. But this is very nice. This is because those are tough. Those are not easy to process. I mean, those are kind of nasty. Look at those. A lot of formatting in there. A lot of. I mean, I should have infographics. I should have expected it because you have graphics in there. So very impressed by that. The ability there. These are all table QA ones. Once again, very nice. Looks really good. I mean, here's the other thing we can look at. When we look at some of the bounding box ones, look at, like I said, I just don't think an LLM can understand what that means when you just provide like bounding box information. I mean, the plain text version that just reads left to right outperformed the bounding box versions across the board. Look at that. Like I said, those are wasted tokens. That's wasted information. You just saying here are the bounding box coordinates of this text means nothing to an LLM that is next token focused. It means literally nothing. So I'm not surprised. But I don't know what you thought. Look at that. Huh. Cool. Never seen it. It looks nice. Cool. So let's take a look at table 2. Once again, we've got invoices. We can't see their data set for these, so that's kind of annoying. Well, we can't see the I actually don't care that we can't see the data sets because theirs didn't really perform. Well, okay. Why would you put your own proprietary model here? I mean, honestly, I see why they're doing it because they want you to use their proprietary model. And this is a nice way to show that their proprietary model is all of a sudden the best. And by far the best. Their model being the best at their own internal data sets. Come on. I mean, I'm sure it is. I would hope it is. It's your own data sets. But whatever. I still don't even mind. Once again, spatial format, best one, pretty much across the board. So, it's compared to the other options. I do wish they. Well, I don't know why they didn't run these. Okay, well, whatever. Looks fine. Table 3 shows. Yeah, so on the invoice data sets, ChatGPT. Well, it's once again. Well, actually, spatial format here Does not do the best. Look at that. Look at plain text. Look at plain text coming in strong. You get spatial formats the best on these, the challenge data sets, but not by that. Well, yeah, I mean, plain text, not bad. Look at plain text. Yeah. Solar actually outperforms. Oh, no, nah, by 0.4. I wouldn't consider that. I think ChatGPT is still a better option than the open source Solar. But of course, that model is not fine-tuned. Fine-tune that model, a little bit of a different game. Everyone knows I'm a big fan of that. Let's keep moving. Well, the impact of document layout on depths on our story challenge data set, which features demanding questions on specific table cells. Can we see a couple examples of this? Specific cells and tables. That's what I like to see. Just show me an example. I guess it's these. Yeah. Yeah, they're receipts. Okay. I am stunned that plain text did as well as it did. I really am. I thought the spatial format would add a little bit more on the invoices. Interesting. Not surprised that ChatGPT performed better. I think this is, I don't know. Well, I don't know. I don't know if this isn't a big enough variation for me to consider Solar better than ChatGPT at sorry, but I do consider this big enough. So take that how you will. So with impact of that, we found that LLM works surprisingly well. Answer 59 with all verbalizers and 82 with the plain text verbalizer. Yeah, it did. It's wild. Good for them. Overall, the challenge cases were more reliably solved by the spatial format strategy. Indicates on a limited number of manually inserted samples, better resiliency of the spatial format verbalizer with respect to OCR layout misinterpretations. Cool. And the noise, they're talking about the noise models again. I don't really care too much about that. Investigated techniques for adding layout information to prompts for instruction-tuned LLMs to enhance document understanding. Chat about the data sets and the results. And yeah, looks pretty good. It was very cool. Glad they laid it out against LLMs as well as sort of document understanding models that are kind of built to do that. I'm glad they did that. Prompt templates. This is just additional stuff, so you can see that down there. Token analysis. I don't care about token analysis. Well, actually, I kind of do, because once again, when you use these bounding box ones, you get a lot more tokens than you do just with the spatial formats. This was my argument above, was that you're adding all these additional tokens and you're not getting any extra information. Every token you add to a prompt affects the model's understanding of the specific task. So you want to try to keep as low amount of tokens with as much granularity to your task, right? You don't want to be removing tokens that ruin your understanding of what you're supposed to do, but you don't want to add tokens that add no value to the model. And that's essentially what the bounding box one does. This one, although more than when we just use the vertical, is a good trade-off, because there's more, that information is valuable. Those extra tokens are valuable. We clearly see that in the results. So glad they put this there. More information about just the average accuracy across the board. Yeah, spatial format, big winner. Challenge examples. Yeah, look at those. Look at those. Those look nice. And there we go. So I hope you enjoyed this. I hope the analysis and understanding makes sense. I hope that the reasoning behind why you want to do this and how it compares to just using, an LLM with, just left to right reading OCR, why this makes sense, even though in some of these cases it didn't outperform the document understanding systems that are built for that. The whole reason they're built for that is that it clearly outperformed just plain text or some of the other options you see people use. It clearly was the best when you add this sort of spatial information. So I hope you found this useful. A link to this will be down below, and I'll see you guys next time.